Hello everyone. So today we have again picked one of the medium question from the Leetcode, which is basically named as combination sum. So what it says, we can just go through the problem and understand the given example, and we'll try to write the solution for this. So it says, given an array of distinct integers, so like all values are distinct, named as candidates of I. So this is the given input list of integers, and a target integer target. So this is the target integer. It says return list of all unique combinations of candidate where the chosen numbers sum to target. And you may return the combination in any order, which is fine. So we have to return a list of unique combination, which will return give us the target sum. It's what it says again. The same number may be chosen from the candidates unlimited number of times. Like we can use one of the number multiple times. Another thing it mentioned, two combination are unique if the frequency of at least one of the chosen number is different. So at least one of the numbers, the frequency of one of the number is different. We'll understand what does it mean. The test case generator asserts that the numbers of unique combinations sum up to target is less than 150 combination, which is good. So now let's try to understand the input, the examples. So here we have 2, 3, 6, and 7, 4 values of the input, the candidates of I, and the target which we have to find the 7, the sum. So we have to give the list of input. So one of the candidates which can be directly the 7. So we can think of one of the candidate can be a 7. What about the another scenarios? Can we find something 3 plus 4, nothing, like 6 plus 1, nothing, 2 plus 5? No, we don't have it. But it says the given input, one of the input can be used n number of times, multiple times. So let's try to figure out the another way. So if we are going to choose 2, then we are sort of 5. What if we choose again 2? Then we are sort of 3, and we can see we do have 3 there. So this could be one of the given scenario. So this is what we have into the output, 2, 2, 3, and the 7. And it also says we can return combination in any order, which is fine. Another thing is, it was talking about the unique combination. What does it mean? Let's say if I go ahead and permute this, like what do we mean by that? If I write 2, 3, 2, right? So this is like in my output, I can't have 2, 2, 3 and 2, 3, 2. I can't have both of them. It says, the frequency of at least one of the numbers should be different. So here, what do we have the frequency of 2? So 2 is coming 1 and 2. So the frequency of 2 is 2, frequency of 3 is 1. And in this scenario as well, frequency of 2 is 2, frequency of 3 is 1. So for all of them, the frequency is same. At least, one of the frequencies should be different. Then only we can say, this combination is unique. So here we have to ignore this combination. So yeah, we understood this scenario at least, like, what do we mean by given these things. So let's go ahead and try to, create the recursion tree for that, how we can, uniquely define that. So for that, let's go ahead and choose it. Our input was our input was 2, 2, 3, 6, 7. So let's go ahead and choose the pen. We'll see. Our input was 2, 3, 6, and 7. So how can we define our tree? The best way by which we can ignore the duplicates. Let's say if you are choosing in one of the tree, like in one of the flow, we are going to include one of the number. In the second flow, if we exclude it, then we know that on the left hand side we'll have on all the combination where we have the 2, and in the another combination, another flow, we won't be having the 2 included there. So that was the case, in output you're finding like 2, 2, 3 will be, let's say, coming here, but here we won't be having 2, 3, 2. That scenario won't be happening because of this. So let's go ahead and see what our output list will look like. output list basically which we are going to post it here. So we'll see, since we have included 2 here, so our output list will have the 2 only as of now. What about our input? So our input was currently, let's say we are pointing to this particular index. So we can include it n number of times. So we won't be increasing, our index from here. So our input should still look like 2, 3, 6, 7. And what about the current sum? So current sum, since we have included 2, so current sum would be 2. So it's less than 7 as of now. In this particular flow, since we're not going to include 2, our output list will be empty as of now. And what about the input? So we are now going to increase our I from 2 to 3, like our index will come point to 3 here. So now our input should look like something 3, 6, 7. And what about our target sum? Target sum would be 0. Let's go ahead and do it here quickly, and we see if you're going to include 2 again here, we are going to exclude 2 here. So our output will look like 2, 2. And what about input? So we can include 2 again n number of times. We are not going to increase our I pointer from here to, we are not going to move again. So it will look like 2, 3, 6, 7. And what about our target sum? That got updated to 4, which is still less than 7. And in this particular flow, our output will be 2. We are not going to include 2. So this will have 3, 6, 7. We are going to move our pointer from I2 to 3. And what about our target sum, which is equals to 2 as of now. Let's go ahead and see now another scenario. If you're going to include 2 or not going to include 2, that could be the same, right? So if you're going to include it, it will be 2, 2, and 2, 6. And our input would be 2, 3, 6, 7. We are not going to, increase the I pointer from here. And what about our target sum? It would be 6. So we know that for this particular scenario, our output should be 2, 2, 3, something like that. So if we are going to move ahead here in this flow, right, after 6, either we are going to include 2 somewhere future, 3 or 6 or 7, right? All will lead to greater than value of our target sum, which was 7. So everything will be greater than 7 here. So we are going to get the dead end, like we have to exclude it in the future, like return back. What about here? So here we have 2, 2. Input will look like 3, 6, 7. And target sum is still 4. Same as that. And we have just increased our I from 2 to 3. Now, again, in the future, we have 2 options. We can go ahead, include 3 or exclude 3. So if you're going to include 3, how will our output look like? Output will look like 2, 2, 3. Our target sum, since we're including 3, so it should be 3, 6, 7. We are not going to increase our I pointer. And now our current sum would be 7, which is equal to our target sum what we had it. So our target sum which we had to achieve was 7. So now, so this is one of the the valid case, we have got it. So yeah, from here we can return and push this into our output list. And we know that if you're not going to include 3 further in this tree, that will return us some invalid scenarios. Cool. And similarly from here as well, we'll be having 2 scenarios, either include 3 or exclude 3. We know that this won't lead us to a correct solution. So our output will be still empty. Our input, we are going to move our index from 3 to 6. So input should look like 6, 7. Output is still 0. We can either include 6 or exclude 6. So here we know that this will lead us to some invalid outputs. And we're going to increase our I from index from 6 to 7. Output is still 0. Now here we'll see if you're going to get the valid scenario now. We're going to include 7 or exclude 7. If you're going to include 7, then output list will have 7. We still have the 7 here. Our current sum is equal to the target. So this is one of the valid scenario. Here, what we'll have, here we'll have the empty. and we have to increase our I pointer, which will go outside the index, right? So now this will be an invalid scenario. We have to return from here. So now in our output list, what we can do, we can push these two valid scenarios like 2, 2, 3, and we can push 7. So this is what we have to do it. So this is typical backtracking problem. Let's go ahead and try to write the solution for this. So we need one output array. And now let's go ahead and write our DFS. So we can just go and see what we are doing it here. So either we are including the given input current index in our output list, the probable output list, or we are going to exclude it. So we just need one of the current list, the probable list for us. So let's go ahead and write the function definition for this. So that will be current list, which will be probably either that can be pushed into our output or we are going to ignore it. So that is the one thing which we needed, this one. Then we need some sum to figure it out, whether it's equal to our target or not. So we need some sum. Initial condition would be like we are going to start from 0. And then what we need it, we'll see. And then basically we need our the current input. So we need some pointer where basically we are currently pointing to, whether we are pointing to the 0th index, or if we are not going to include it, then we are moving our index from 0 to like we are doing plus plus. So we are basically pointing to the next index. So we need one of the index. So we just need one of the index, let's say I. At the start, basically it's pointing from the 0th index. So this is what we all need. Now, what is the valid scenarios for us? So valid scenario is when our current sum is equal to the target sum. So if sum equals to target, then what we need to do? If that is the case, then we have to push our the current probable list into the output list. That's what we just need to do. So we can do output.push our current list. Now, since we're writing this code into the JavaScript, so, and both of them are, the array. So in future, if you're doing some more operation, this current list, if you're going to change the current list, this might go ahead and update the output list as well. So for that, basically, we need to make a deep clone of this. In JavaScript, there is one way to deep clone or make a deep copy using the spread operator. So this is the way to make, the deep clone of that. And now, since we have it, the answer, we can just return from this, the function. Now, what are some boundary conditions which we can think of? So one of the condition, when we are going out of the index, right? Like our index is going out of the given input array. So if I is greater than or equal to candidates.length, then we have to go out. Or what was the condition? If our current sum basically is going to be in this particular scenario, like our sum was 6, if you're going to include 2 or something, right? The sum would be greater than our current target sum. So if our sum is greater than target, if this is the case, then we can just return from here. We don't need to go and do the calculations. And what were the two operations we're performing here? So if I'm at the current index I, I'm just going to either include this or exclude it. So if you're going to include it, then what do we need to do? Or if you're going to include it, then we are kind of pushing this number into our current probable list. So we can say that let's push, the current item into the current list. Current list dot push candidates of I. And then we can just go ahead and call our defense function again with this, to make all this call recursively with this data, since we have pushed it. So what we need the current list when we are posting the current item, then what we are doing? When posting it, so here our current sum was 0, right? So what we did, when you're posting it, we are just checking the current number and adding into the previous one. So it got updated to 2. When you're again going and including the 2, then this is getting updated, added into the previous sum. So 2 plus 2, here we got as a 4, right? So our current sum will get updated, sum plus, candidates of I. And then what about the current index? Are we going to increase or decrease? So whenever like we are including it, like we're considering this number, then our index is pointing to the same number in each, left hand side in the left flow. So our index would be pointing to the same index. Cool. What if you're not going to include it? If you're not going to include this number, then this number shouldn't be part of my, the current probable list. So I can just go ahead and pop it. Since we just push this number to call the left flow, we need to, pop now the current number from the current list. So now we won't be having this number into the probable list. Then what we are doing, we just need to call the DFS again. And here what we are doing, our current list would be the same. We have, correct current list. What about the sum? So sum is exactly, exactly similar to the previous, currently whatever it's coming from the parent. So you can see if you're not going to include it, sum would be exactly same. So we are not going to, add it the candidates of I. So sum would be the same. But what about the index? So if you're not going to include it, we are, moving our index from 2 to 3. If you're not including the 3, then we are, moving our current index from 3 to 6. So basically we are doing I++. So I+1, we can write it. So this will give us, provide us all the possible solutions into our current output array. After when we are done with this operation, at end of our function, we can just return, output. Cool. Let's go ahead and try and see what it does. Yeah, so it was able to pass the correct current, the test case. Let's go ahead and submit it. Yep, so we just submitted it a few seconds ago, and we were able to, it got passed with the all test case scenarios. Let's talk about, the time and space complexity. If we talk about the time complexity, it would be 2 to the power, what do we say? 2 to the power, how many targets, like how many times those operation we're going to do it, the number of target, like the target which we have, the 2 to the power 3. Whatever the space complexity, since that should be what we go of n. Yeah, because we are going to use an output, and the maximum length, which we can have, like we can include all of them multiple times. So it won't even go, more than we go of n. So yeah, this is the current time complexity and space complexity for this. That's all we have for this, session.